Well, hello again, and my desk is messy yet again, so let's just call this another episode of my messy desk. What are we doing today? Well, a highly respected acquaintance of mine has found himself in hospital. He's been suffering from cancer for a number of years now, and we are a little concerned that this might be the last time we really get to show him my work. So this gigantic meter here he actually gave to me, along with this one here and many other things. But this is one I've been holding for quite a while to try and find a special project to do just for him. And so basically I figure now or never, really. So yeah, I think I've got an idea. I wanted to make this meter useful for so many different things, and I'm trying to work out, well, if I mount it into a box, I've got to commit to one particular purpose. Obviously I can't use it for its originally intended use because, well, I'm not in an oil field, and I could replace that back card in there, but I don't want to do that. That would detract from its original purpose. So yeah, I've been thinking and thinking, and I had a bit of an epiphany. I drew up a really quick, really crudely drawn diagram here, and my idea is to hook it up with a series and a parallel trim pot, or potentiometer would be the correct word, so that I can adjust both the current and the voltage across it. So I'll have a parallel and a series one. So I do have a big box full of old components from a RAF-based radar station, and I have a nuclear weapons control panel I made for my daughter out of those same vintage vintage switches and dials. So I'll probably pull a few of them out of that project because she doesn't play with that anymore. I never actually finished it, and time is of the essence. I have a bunch of MDF which I think I'll paint up, or I'll put a stain and varnish in and make it look very nice. But I think that's probably where this is going to do, is get put into a box as a general purpose meter with some kind of adjustment and whatnot that I can use. So anyway, let's get on with the design here, and I'll make up a box to fit this and some dials, and we'll lay out some stuff that we need. Alright, I'm going through my mystery box of vintage stuff, and I have found this was donated by Mick's iPhone Repairs. This is a 10k ohm multi-turn pot. I think that's going to be ideal for this purpose. And for one of the others, I have some of these other potentiometers that were in use in the old nearby RAF-based radar unit, which would be quite applicable because this acquaintance of mine, he actually worked at Red Lake radar station, along with many other things in the Navy. And these are Australian made, used in radar units, so I think that is highly applicable. And I have a number of switches here. I think I can probably use some of these for isolations to change the configuration. So yeah, this might do the job. Well, these are just indicator lights. I have some more switches like that. They're serviceable with backlights, and I have the knobs and stuff with all the labels on them, so I'll pick a couple of appropriate labels. It'll look nice, and probably very familiar to him as well. I'd very much like him to see this before the time is up, if you will. So yeah, let's pick out a few of these components. I'll measure them up and we'll find some room to fit them. These will work well enough to be able to fit some switches into those holes. I'll use them as a reference measure, and I'll pull some other components out shortly. Now, this is the originally the toy that was going to be for my daughter. She's kind of moved on from this kind of thing. This was originally going to get an 18 mega Arduino built into it to control everything and have a whole bunch of relays and electromechanical stuff, but she's got bigger interests at the moment, and particularly I'm thinking that I might be able to use some of these to switch in resistor banks and stuff. So yeah, I'll figure out which ones of these I want to use, and I'll be removing some of them. So yeah, let's get on with actually picking out the components, deciding exactly on our circuit, and then we'll design the box and panels accordingly. going to take a moment to firstly take off my glasses and pause for a moment. I've just got notification that I've missed the boat with this project. We lost the late and great Ken Anderson earlier today. I also hear word that the very first approval of the Assisted Dying Act has taken place in Victoria, and Ken was a very great advocate for such a thing, and he'd always said that when things got too much that he was going to exercise his right. So while I don't know just yet, but I suspect he's exercised that right. He'd been holding on against cancer and all the odds for that approval to go through. So if that's the case, then he probably went, I don't know, quite painlessly. But it looks like I'm going to be going to the museum this weekend and flying the flag at half-mast in his honour. So this has now become a tribute project. In lieu of a longer spiel or speech, I'd just like to say this man was a true gentleman and somebody who very genuinely earned my respect. And at this stage, he'll never lose it. So let's get on with this project. I'm committed to finish it now. It has to be done. There's nothing for it. Alright, well, it's the next morning. And yeah, didn't sleep all that well last night. Oh, we have a new sound card to install on the workshop machine as well. Got a tin of rations here. I'm hoping, if we're really lucky, I can get one of these rations off to Steve 1989 MRE info, I think, on YouTube. He hasn't got back to us yet, so I don't know if we'll do that, but if I can, that will be a video for the museum. Made some upgrades to my laser cutter. I've moved the extraction fan up. Now we need to decide if we've got enough timber. I've been playing with some resin here, it's very messy. Now, I've had from Lenard Audio, in favour of a little laser cutting job I did, he donated some 3mm timber, or 3mm MDF. I think this is cut to size for my laser bed. I think that's going to be ideal. Alright, so let's get all this loaded up, and we'll load up the files and we'll start cutting this job. I had the fan up and my apprentice decided it was time she's going to come and help. And we have a project for her mother at some point here too. I need to work on this rocking chair. But yes, she's donned the appropriate PPE, and yeah, we'll be getting to it shortly. And my apprentice knows exactly what to do when she's out here. She's straight in, cleaning out all the spent and loose bits and pieces, all the offcuts, if you will, from the laser cutting process. So she's going to stick a couple up there too. Reserve a couple of her favourites. And this is something Ken would have probably really appreciated. He'd adopted my apprentice here as his own little granddaughter. Alright, that's everything laser cut. And I had to make a quick change to the writing here. It was supposed to be the date of manufacture, but given again that I missed the boat, I thought it'd be fitting to put the year of his reign in, I guess, for lack of a better word. You'll have to excuse my language at the moment. My brain's a bit mush. So what I do need to do though, however, is get some stain and varnish on this sheet so it can dry. And then I'll go and assemble the rest of the box. And while the glue's drying, then I can mount the panels on this. I've got it all planned out in the back of my head. It'll make sense. You'll see how it goes together. Now is the moment where I utter expletives unintentionally. I've got the front panel here and I have the meter over in the background here. Because I now know that I will never ever get another one of these, I'm putting down a T-tail down here to make sure I don't scratch it. So this is the meter. We're timed to see if we can marry these up to the front panel and if my measurements are correct. And you can probably hear my apprentice in the background with the aftermath of her finger getting stuck in the door. Luckily though, no broken bones. Alright, I can see here from the angle that 2 of my holes are correct and 2 are not. So you can see here, these 2 holes are correct, these 2 are not. And I left quite a lot of leeway for adjustment here given the weird relation of positioning to this circle. It wasn't concentric. So although I can see through the gap here, they're only just not lining up. So I think if I put a little bit of pressure and a bit of a wriggle here, they'll leave a bit of mark in the varnish and I can manually drill those holes. It won't look too bad, they'll be covered up. Alright, let's move this over here gently. Alright, well it's in. The next challenge I didn't anticipate is working on what thread size these are, and I'm going to guess they're imperial, but we'll cross that bridge as we're at it now. I want to check for alignment in relation to everything else and see if it's square. So that's looking good. Alright, so let's come out a little bit. That's pretty much how it's going to look position wise. That's going to be quite nice. Another little trick I should show you now that I'm insulated. This needle is sensitive to static electricity. So as I do this, it's going to lift off and eventually stick to the top of the screen. If I can run one finger along here, you can see it moving a little bit. Part of it is because I have an anti-static strip here on my bench, and that is grounding some of what I'm doing because I have to touch it to touch anything on the bench. So that does negate some of the effect, but you can see if I just run my hand along the surface here slightly, the static electricity will influence it. So very interesting, but that's how sensitive these old meters are, more so than a lot of digital multimeters. So that's one of the reasons why I'd like to use this meter for many different purposes, and the way this is going to be configured will really make that a lot easier. So let's get on to finding these nuts and bolts. Alright, well, I'm reasonably sure these are imperial, but I did find some very close metric matches. Being these are brass threads, I've been very gentle. They're tightened up just enough to hold it in without falling out and not rattle, but no tighter. And what I'll do is put a small amount of thread locker on there, just a tiny little bit. That will hold them in without damaging the original thread, and then it can be removed easily should I find the correct threaded nuts and bolts for this. So I'm trying to be gentle here, but it's in and it's secure. So we'll start mounting dials in shortly. Alright, we have these removed. I have a couple of caps here which I'll clean up, 2 of the short shafted pots, 2 knobs, 2 of the dual gang illuminated switches which won't be illuminated, and the lock rings for them. I also found 4 LRFs which I can probably use to put rubber feet on this project. Right, so let's get on with putting them in. Now, I did realize that originally I was going to use 2 of these banana plug terminals for an input, but one of the things that Mick Edwards had found for me is a little dual gang banana plug input, such as the ones I've used over here. So they will be good. Alright, well, we've made some progress, and Tinkerman Mick has showed up and brought me the final part that I was looking for. Now, here's our circuit diagram, and he's dropped off a couple other things for me. This is our push button switch for our parallel resistor circuit, and that is connected thusly to the meter. This is probably not quite represented correctly, but this is our series connected. So what happens here is we have this wire here is our negative input and our positive input. Our positive travels through here and straight up to the meter. These two are the parallel resistance circuit. When the button is switched, it will obviously short across these contacts, putting this trim pot in parallel with the meter. Over here, these two are the series circuit. When this button is pushed, it will short out this resistor, removing it from the circuit, or this trim pot rather. And we have a fuse holder in here with an AG3 fuse, if we want to put a very low rating fuse to help protect the meter. The next step will be inserting these in those two holes. So we'll get on with that. Alright, we've got the finished front panel with the little donation from Tinkerman Mick there. I'll put a link to his YouTube channel. Now we need to see if it will actually fit the box. And it does without interference. It does very nicely. So that's pretty close to what we'll be looking for. And we have some LRFs to fit in a minute. But that's looking rather nice. So the next step will be to test to see if everything works in situ. And we'll do that in a moment. And if it does, we'll neaten up some of this wiring and we'll get on with the rest of the box. Alright, so I think we've finally got this nutted out. So we have the, where are we? I've got parallel in here both. So I've got series circuit and series resistance engaged, parallel and parallel resistance engaged as well. I know the voltage burden is 4.98 volts, very close to 5 volts. So we're going to give it 5 volts here. And now we can adjust our series resistance and we can adjust our parallel resistance, which I think this pot is a little dirty, but we'll fix that later. But it does mean we can dial a resistance that I can measure from there. It means if I have a specific project, I can calibrate it at the start of the project and then go back from there. So it looks like our series resistance is going to do a good job. Alright, so I think we've got a useful project. So pretty much now we need to get the rest of the box finished. Okay, so it's found its final home, or for now anyway, until I pass it on to somebody else. This power supply here is actually one that Ken Anderson also gave me, and it's been a very reliable supply. This is one that my father made and it's currently connected to it, and we can see here our meter now works and I can calibrate it for particular jobs, and it's going to sit right up here. So yes, this is probably where it's going to stay for quite a while until I find somebody else that I can donate it to in the spirit that Ken Anderson would have done. And it's going to stay looking after my, holding up my old Dick Smith oscilloscope. So yeah, in any case, that's pretty much the end of this. If I can find a good sample of his voice, I'll put that at the end of this video. So stay tuned for that. But anyway, I hope you enjoyed this. It's a bit of a tribute video. I feel pretty bad that I missed the boat and you didn't actually get to see this in person. But this might end up on his Facebook wall as a bit of a tribute to him anyway, because he's really inspired me to improve all my skills and techniques, and it's something I won't forget. It's skills that I'll live on with and I'll pass on to others. So I'll leave you with this little clip.
Exactly right, and it's amazing. I've often said it. I don't know how you do it. I don't know, because I remember, you know, at HMAS Watson, for example, where I was in 1958, and somebody would come and say, "Oh, there's a fault on so and so," and you'd wander across to where it was, walk in the room, and say, "Oh, it's that." I have no idea how you knew, but you did.
Yeah.
You'd analysed it on the way across and so on. So this is the compendium of useful guff, miscellanea and other odds and ends. So the first page has got at the top, aluminium copper interface anti-corrosion compound, Pentrox A or Alnox at UG. calculating the azimuth of a star, the rising of a star, air breakdown voltage, air voltage, the breakdown of air under voltage.
I needed to actually know that recently. So
Okay, so
I figured it out in the end.
it's about 28 kilovolts per centimetre.
Yeah. I ended up with a value of about 30 kilovolts per centimetre.
That's very close.